Hi, everyone. Am I audible?
Yes, sir.
Yeah. So we will start with prayer. Ya kundendu tushar har dhavala ya shubhra vasravruta ya veena vardanda mandita kara या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिर्दैवैः सदा वन्दिता सा मा पातु सरस्वती भगवती निःशेषजाड्यपहा. Share my screen. Is my screen visible? Hello. Is my screen visible to everyone? Hello. Am I audible or?
Yes, we can see the screen.
Yeah. Okay. Good. Yeah. So let's start for today's session. Like we had a gap of 1 week, and I hope you all of you have a good Diwali break. So today we are going to like focus on the Pushpa 5 or the fifth part of it. In the last lecture, we have covered the left to right techniques and the all from 9 and last from 10 sutra, that is Nikhilam Navat Charam Dashataha. And we have also covered the various 6 different types of usage of the sutra, all from 9, last from 10. There are other various usage of it, but as we uh, keep on learning the techniques, we will see the usage of it. But the main thing about the subtraction and the getting the numbers reduced, okay, or the decimal numbering system, this is a gem of the one of the gem of the sutras out of 16 sutras that we have covered. So Nikhilam Navam Charam Dashataha means all from 9, means all numbers should be deducted from 9 and last number from the 10. That avoids the carry over and how to use the carry altogether in the basic level of mathematics. So, as to revise that, suppose we have learned this in the last lecture, we have to deduct 8,000, like deduct 4,202 from 8,000. So, what we do, we increase the first digit 4 by 1, make it 5, and then subtract from 8. 8 minus 5 is 3. Then we apply the sutra, that is 9, all from 9, last from 10. So 9 minus 2 is 7, 9 minus 0 is 9, and 10 minus 2 is 8. So final answer is 3798. We have covered this in the last lecture. Then also we have covered the reducing the first digit by 1 and giving a leading 0. So if the subtraction is 5000 minus 74, so I add a leading 0 called 07, make it 074. I reduce the 5 by 1, make it 4. Then 9 minus 0 is 9. 9 minus 7 is 2. And 10 minus 4 is 6. So the final answer is 4926. So this sutra we have covered in the last lecture. Also, we have learned the decimal point subtraction. So 10 minus 2.73. So we can easily deduct 2 from 10. So we can apply the formula. So 9 minus 2 is 7, 9 minus 7 is 2, 10 minus 3 is 7. Put a decimal point after 2 digits. In case of n20, we reduce 2 by 1, make it 1, and then apply the formula. 9 minus 3 is 6, 9 minus 7 is 2, 10 minus 3 is 7. So we learn this particular sutra and how to use it. We also learn the left and right subtraction. That is the general scenario 89 minus 72, when the lower number is low, it is easy to deduct. That is 8 minus 7 is 1, 9 minus 2 is 7. Only in case if the upper number is lower, how to do that? So we learned that in the last lecture, that we use the friend number. So we first deduct 6 minus 3 is 3. We cannot deduct 7 minus 4, 7 from 4, 4. So we take a friend of 7, make it 3. What is the friend number of 7? Is 3. Then we simply add the friend to 4. 4 plus 3 is 7. So answer is 27. We learn that. We also learn the friend numbers. Friend of 1 is 9, friend of 2 is 8, 3 is 7, 4 is 6, and 5 is 5. Yeah? And friend number repeats again. Now, in the today's lecture, we are going to focus on one important and interesting concept that is called the digit sum. Digit sum is a technique to add all the numbers in a given number till it reaches to the single digit number. Say for example, if I have to find a digit sum of 83, so I just add 8 plus 3. 8 plus 3 is 11. But 11 is also two digit number. So I again add 1 plus 1. So 1 plus 1 is 2. Okay. Suppose I have to find the digit sum of 521832. So what I do, like 5 plus 2 plus 1 plus 8 plus 3 plus 2. Okay, so again 8 plus 2 is 10. Okay, 5 plus 3 plus 2, 5, 10. Okay, so 10 plus 10, 20 plus 1, 21. So 21, again 2 plus 1 is 3. So digit sum of this 5,21,832 is 3. There is a thumb rule to find the quickest way to find the digit sum of any given number. So what is that thumb rule is that one can ignore the number 9 or set of numbers which add up to the 9 when finding the digit sum. Means you should not even add those numbers. Say for example, out of this number I can simply cancel out 5, 2, 2 because they are made up to 9. So ignore that. 8 plus 1, 9, ignore that. Whatever remaining is 3. So that is the number 3. So you can ignore the number 9 and the set of numbers which add up to the 9. Is this clear what I am trying to say here? Hello? Is this clear what I tried to teach here?
Yes, sir.
Yeah. Okay. Okay. Good. So what is the use of digit sum? We will learn it in 2 minutes. But see, we are also doing our Gita Parayan. Okay. In Gita Parayan, it is a very useful technique. Okay. See, in my Gita Parayan group, I use the Vedic mathematics sutra called Ekadikena Purvena. Means whatever the number allocated, we always allocate the next one number to all the seekers. Suppose yesterday I read the Adhyay 2, then today I will read 3, tomorrow I will read 4, next day I will read 5. So that way it will help to read all the 18 Adhyay in a proper sequence and the cycle repeats. But this is also a very interesting thing that if we are doing suppose in the Parayan 1, the first Parayan, the seeker 1 will always get a chapter number 1. But if the Parayan number is 11, then the seeker first will always get a digit sum of the number of Parayan. Means the Parayan number is 11. So 1 plus 1 is 2. The seeker 1 will always get the chapter number 2. Yeah. If I am doing a Parayan of 15, okay. So the seeker first sadhaka will get always the chapter number 6 to read. Okay, that way it is very easy to find it out. Suppose I am doing a Parayan number 92. So the first sadhak will always get a adhyay number 2 because I can simply ignore 9, keep it only 2. So it is easier to find it out what the sadhak or what the seeker is reading that particular day. Yeah. So this is a simple usage of a digit sum. As a fun, I am telling it. But real mathematical usage, we will see it in next slide. Is my next slide clear? Visible? Hello? Is my next slide visible?
Yes, sir.
Yeah. Okay. So see the cross check. What is the use of digit sum? Digit sum is useful to cross check your fundamental arithmetic operations that we do. What are the fundamental arithmetic operations in mathematics? That is addition, subtraction, multiplication, and division. So digit sum is very useful to calculate your answer is correct or not. Say for example, if I have to add 456 plus 209. So I add 4 plus 2 is 6, 5 plus 0 is 5, 6 plus 9 is 15, C 5, 1 get to the next, so answer is 665. So whatever is the answer, how I can verify my answer is correct? So I take a digit sum of first number. So I can simply ignore 4 and 5. So digit sum is 6. Yeah. I can simply ignore 9. So digit sum is 2. I add the digit sum. That is the digit sum of the number 6 plus 2 is 8. Then I calculate the digit sum of the answer. 6 plus 6 is 12. 12 plus 5 is 17. 17 is again 1 plus 7. That is 8. If the digit sum of answer matches with the digit sum of the problem, then my answer is 665 is 100% correct. You understood? Like what I am trying to teach here? The digit sum is always same for the problem and the same arithmetic operation on the problem and the digit sum of the answer. It always matches. This is the beauty of mathematics. Suppose if you see the 63 minus 37, what the answer is 26. So 6 plus 3 is 9, 7 and 3 digit sum is 10. 10 means 1. Okay, so 9 minus 1 is 8. 6 plus 2 is 8. Sorry, 6, 2 plus 6. The slide should be saying 6 here. So answer is 8. So the answer of the problem, digit sum of a problem and the digit sum of answer always matches. So if my digit sum matches, it means my answer is correct. Okay. Suppose if I take a very simple example, if I take a number 11 into 12, okay. So 11 into 12 is 131. Yeah. Or 11 plus 12 is 131. Sorry, 132. Yeah. So if I calculate that, so 1 plus 1 is 2, 2 plus 1 is 3. Okay, and suppose I take a wrong answer. Suppose the answer is 131, I take it. So digit sum, the multiplication of 3 and 2 is 6. Okay, so digit sum, if it becomes 3 plus 1 plus 1, it becomes 5. So my answer is wrong. So if my answer is 132, then 3 plus 2 plus is 5, 5 plus 1 is 6, 6 to 6 match, it means my answer is correct. Yeah. So we will learn that for multiplication and division as we go along. But digit sum is a technique. Okay. See, even in the first lecture, we have seen the circle of mathematics. We also learn that all the numbers ultimately collapse or boil down to the fundamental 10-digit number, that is 0 to 9 only. Yeah. So the same logic is applicable in the context of fundamental operations of arithmetic. So is the digit sum technique clear? How to check your problems? So you can check your own answers yourself if you use this technique in in any scenario of the fundamental arithmetics. Yeah. So now we will learn, today we are going to learn a new topic called multiplication. Okay. So how to do a multiplication fast. There are various ways and various formulas for the multiplication. Out of that, today we are going to cover a base multiplication. First of all, we will understand what is base. So base is a number, okay, which is same, the number of zeros after the 1 should be the same as number of digits in a given number. Suppose number is 8, means the number of zeros after 1 is 1. So the base is 10. 45, the base is 100. Number is 474747. So 6 digits. So the base is again 6 zeros after 1. Yeah. So we understand how to calculate the base first, or how to find the base of any number. Suppose I have to do 8 into 7. Okay, so 8, the base of 8 is, or base of 7 is 10. So what I do is I subtract 8 from base. So 8 minus 10, the answer is minus 2. Yeah. 7 minus 10, his answer is minus 3. I just multiply 2 into 3 first. Minus minus plus, that's why 3 into 2 is 6. Yeah. Then I cross, in the cross formation, I can deduct 8 minus 7, sorry, 8 minus 3 or 7 minus 2. Answer is same. So 8 minus 3 is 5 or 7 minus 2 is 5. So the answer of that 8 into 7 is 57. The beauty of Vedic mathematics is that whatever the logic applicable to one digit is applicable to n number of digits as well. Okay. The same logic is applicable in the context of 94 into 96. 94, what is the base number, is 100. So I find the difference. 94 minus 100 is minus 6. 96 minus 100 is minus 4. So 6 for the 24. We just check how many zeros are there in the base. 2 zeros. I got the 2 numbers. So I don't need any adjustment. Then 94 minus 4 or 96 minus 6. Answer is 90. So answer is 90, 24. 90, 24. Yeah. So I don't need even to do a complex calculations. Okay. I simply deduct the numbers, find the difference between the base, multiply the difference of the base, and deduct the difference from the given numbers. That's the simple steps to find the answer of multiplication. Is this clear how I did it? Yeah. If you want, you can unmute yourself and then it will be easier for you to speak. Yeah. Yeah, you can unmute yourself if you have any questions. Yeah. Is this clear?
Yes, sir.
Yeah. Okay. So let us go for the next some practice. Suppose 8 into 9. So I find the difference. 8 minus 2. Okay. 9 minus 1. So 8 minus 1 is 7. Okay. And 2 minus 2 minus 1 is 2. So answer is 72. 78. The difference is 7 minus 2. Okay. Or 8 minus 3. Answer is 5. And 3 into 2. 3 to the 6. So answer is 56. Why I am taking a minus sign here? Because in the future, we are also going to learn that if the number is above and one number is below, if number is all above base, how to do it? Okay. Because if the number is below base, that's why we are doing subtraction from the 8 minus 1. Okay. For example, 94 or 94, what is the difference? 6. So 6 6 is 36. 94 minus 6. So answer is 88. So answer is 88 36. Is this clear? Suppose, can anyone tell 97 into 89? 97 minus 89 minus 3, because that is easier to do. And 97, all from 9, last from 10. So 11 into 3, 11 3s are 33. So answer is 86 33. Yeah. Suppose the base is 1000, 999 998. The difference is 2. Okay, so 999 minus 2 is 997. And difference is minus 2 minus 1. 2 ones are 2. But the base has 3 zeros. That's why I add 2 leading zeros here. So it becomes 997002. Clear? Is this third sum clear?
Yes, sir.
Yeah. If it is not clear, you can ask me. Yeah. Okay. Now, is this base technique clear? Base multiplication clear and digit sum clear to you? Yeah. Okay. I can give you few sum for practice if you have.
Could you write 97 multiplied by 89 vertically
Yeah, I will do
and
that.
explain
Yeah.
again?
Yeah, I will do that. Yeah. Just one. I will try to use the whiteboard here. Yeah, is my whiteboard visible?
Yes, sir.
Yes.
Yeah. Okay. Suppose,
Not
okay,
yet.
not yet visible. Whiteboard visible.
Preparing. Yeah, I can see it now.
Yeah. Okay. Suppose, what was the problem? 9789. Yeah. Yeah. What is the base? Can anyone tell me the base? Base is 100. You can talk during the class, no issues. Yeah. So 100 minus 97, answer is minus 3. Yeah. 89, 100 minus 89. So I use the formula all from 9, last from 10. 9 minus 8 is 1. 10 minus 9 is 1. So answer is minus. Clear? Okay. So 11 3s are 33. Yeah. In the base, there are 2 zeros. I get the 2 digits here. Okay. So it is fine. Either I can deduct 97 minus 11 or 89 minus 3. What is easier? Deduct 89 minus 3, because I'm lazy. So I simply write 86. Yeah. So
86.
89 minus 3. So
So,
answer is 86 36. 86 33. Is this clear?
33.
Yeah.
Yes.
Yes.
Clear? Is this
Yeah.
clear to everyone? Yeah.
Yes.
Okay. Now we will take another, say, 3-digit number. Yeah. 992. I'm just picking up any random number near base. Yeah.
992 multiplied by
997.
7.
Okay. Tell me what is the base?
1000 minus 992
Yeah.
is
No,
equal to
what is the base?
minus
1000. Yeah.
1000.
Yeah.
1000.
So what is the difference? 992 minus 1000 minus 992 is 8. Obviously, 9 minus
8.
9 is 0, 9 minus 9 is 0, 10 minus 2 is 8. Yeah. What is the difference? 9 and 7? 3. Clear?
Yeah, 3. Yeah,
8 threes are,
24.
I write 24. Yeah. How many zeros are there? 3. How many digits are there? 2. So to make it 3 digit, I just add 0. Clear?
Yes.
Yeah.
9,
Then
9.
9 and 2 minus 3 or 9 and 7 minus 8. Whatever it may be. Any one step you can choose. Yeah. Choose the easier one. 992 minus 3. So 989. Yeah. So answer is 989,024. Is my final answer. Clear? Is this problem clear?
Yes, sir.
Okay, good. Yeah. So today we have learned two important techniques, that is the digit sum technique and the base multiplication near the base, which is below the base. In the next lecture, we are going to learn above the base. Yeah. See, and you can, like, just let me share my slides back. Is the slide visible to everyone? Yeah?
No.
No,
Good.
not yet.
Not
No,
yet.
not it.
Is this visible now? Sorry. Not yet.
No, no.
Yes. Let me first. Is it visible now?
Yes, sir.
Yeah. Okay. Good.
Yes.
So today we learn the two things, that is the digit sum technique as well as the base multiplication first part of it. Okay, we are going to learn multiple ways of doing multiplications for the small number to the large numbers as well. Yeah. So the, as I said, like, first I'm going to teach you this base multiplication for the number above the base. Then we are going to, for a very large numbers, how to do it orally. Yeah. Even this technique is very useful to do it oral calculations. Okay, let us focus and learn the oral calculations, how to do it. Okay, I will give you, if you have pen and paper, just write it down, because I'm trying to tell you the problems orally. Yeah. Suppose the problem is you have to multiply 85 into 98. 85 into 98. Yeah. So how to do it? 85, what is the difference from the base? Is 15 minus 15. Yeah. 98 means what is the difference? Minus 2. So 15 to the 30, and 85 minus 2 is 83. So answer is 8330. Clear? So even with this technique, we can multiply 85 into 98 orally. Is this clear how I did orally or mentally?
Yeah.
Yeah. Okay. So let us take one more practice example. Okay. Can any one of you can tell me how to calculate it? Yeah. Suppose my problem is 87 into 95. 87 into 95. Okay. How you will do it? Anyone can tell. Hello, are you there? Guys, if you could participate actively, that will help me.
Yeah,
to
yeah, yeah.
Understand, are you learning, listening or not? Yeah.
So 100 minus 87 is 3, and 100
No,
minus
100 minus
95 is
87 is no, 100 minus
13.
87
Sorry,
is
13.
13,
13.
correct? Yeah.
And
95,
100 minus 95 is 5.
5. So
So
13,
that
5.
makes it 65 in the second half of the answer.
Yeah, correct.
And 87 minus 5 is 82. So answer is 8265.
Perfect. Perfect. Yeah. So this help us to do it orally even. Yeah. I hope you understand how to do it. Once you understand the technique, it is very easy to do it orally as well. Yeah. And the more we practice on a paper or pencil as well as orally, it will increase our brain capacity like in multifold way. Yeah. So it is very useful technique for our mental growth as well. Yeah. So let us maybe move on to the next slide. See, today I wanted to talk about one important subhashit, that is Sukhartinam kuto vidya nasti vidyarthinam sukham. Sukharti va tejet vidyam vidyarthi va tejet sukham. Means those who like desire for the sukha means happiness. Okay, obviously they will kuto means they will does not get or attain the knowledge. Okay, those who run behind the happiness will never get a knowledge. And in that particular context, the vidyarthi means a student, okay, will never find the happiness, because the lazy people get feel happy, and student shouldn't be a lazy person. And Sukharti va tejet vidya means those who desire for an happiness must give up the hope of learning. Okay. And Vidyarthi va tejet sukham. Okay, means Vidyarthi, the student must give up the hope of happiness. What this Subhashit was trying to teach us, that student must be doing very actively or doing activities in their student life. Because in our Gurukula system, student, when they were like studying in Guru's home or in Gurukula, they used to be given lots of work, household work, work from farming, work from planting, looking after the cows. Okay, so all those work is given to the students so that they will not become a lazy, and they will learn their day-to-day life activities as well. So the student who desire for an happiness or laziness, okay, will never get a knowledge. So student or the vidyarthi must always take an efforts, because as I as we learn in the last class as well, that those you can buy money, you can buy the books, but to get a knowledge you need to study. And to study, obviously you need to give a time, you need to give a dedication, you need to put a efforts to do that, because without efforts no one will get a knowledge in this world. Okay, so we need to give or sacrifice the happiness or sukham. Okay, sukham is an broader meaning in the Sanskrit, that the mind when it thinks about the which is favorable thing in our life, it is called sukha. Okay, the things which is favorable to us, or which is uh, uh, like which is good for us. Okay, or which is makes us make our mind happy. Okay, that is called a sukham. Okay? So that sukham should be given up. Okay, means we should give up that kind of an laziness, we should give up the happiness, so that we can achieve the knowledge. And hence I tell all my students to do study. Okay, study means what? Is to repeat the same thing again and again and again. Okay, so one should always practice, one should always do the homework, one should always go back to the old classes and go back again and find it out what we have learned that time. Because see, our human brain keeps on forgetting the things after every 15 days. Like there are certain percentage of item if we do not learn or focus while learning, we may forget. Okay, so to avoid from forgetting those, so that it becomes firm in our brain or firm in our mind, one should be either first of all very focused or ekagra when learning in the first place itself, or one should be doing it again and again and again practice, so that it will remain firm in our brain or in our chitta. So knowledge is always an activity. Someone who wanted to achieve the knowledge must give up the happiness. That is what the Subhashit wants to tell. Okay. So I hope you like the today's class. If you have any questions, feel free to ask. Otherwise, if this our class session ends, you can join the same link again, and I'll be there to answer your questions. Yeah. So if you have any questions, feel free to ask. Is today's lecture clear?
Yes, sir.
Yeah. Good. Good. Yeah. Any other questions you have? Yeah. If not, then we will stop and you can ask me the questions on a group. I will post this video as well as the slides and the homework that is given to everyone, so that you can do your homework as well for this particular today's lecture. Yeah. Yeah. Thank you. Thank you very much. And have a nice day.
Thank you, sir.
Yes.
Thank you, sir. Thank you so much.
Thank you,
Thank
sir.
you so much, sir.
Thank you.